GCSE question of the week, week 5. Okay, let's have a look at the foundation question first. So what do we got? Mr. Brown and his 2 children are going to London by train. An adult ticket costs £24 and a child ticket costs £12. Mr. Brown has a family rail card, lucky him. Okay, what does the family rail card do? Right, it gives us 1/3 off adult tickets and it gives us 60% off child tickets. So this question's asking you to cope with fractions and percentages. Work out the total cost of the tickets. Okay, let's start with the adult ticket. So we've got an adult ticket at £24. But we know that Mr. Brown's rail card gives him 1/3 off that price. So I think perhaps we could start with finding 1/3 of £24. Okay, so we want 1/3 of £24. Now you know that I like to change that of with a times, so that's the same as saying 1/3 times £24. Again, it really just means we can do 24 divided by 3. That's going to give us 1/3 of the 24. So 24 divided by 3 is going to give us £8. So I think he gets £8 off the price of his ticket. So what's the price of his adult ticket? Well, it's £24. Subtract £8. Okay, that's going to give me £16. So I think the adult ticket's done. It costs £16. Now let's have a look at the child tickets. So the child tickets, what have we got? Okay, we've got a child ticket costs £12. And this time we get 60% off. So we need 60% off. So we could either find 40% here or we could find 60%. Okay, so how are we going to do either of those? Well, there are lots of ways we could do this, but maybe we could find 10% first. It's a non-calculated paper, maybe that would be the best way. So 10% of £12. Well, I reckon we divide that 12 by 10. We're going to get 10% is £1.20. Okay, now he gets 60% off. So we could find 6 times that to give us 60%. Okay, but then we'd have to take that away from the 12. Okay, so why not just find 40%? 40% is how much he's got left to pay. So if we find 40%, well, it's going to be £12. No, it isn't. It's going to be £1.20, sorry, £1.20, which is our 10%, multiplied by 4. Okay, so that gives me £4.80. So because we've worked out the 40%, that's how much left he's got to pay. So the child price is £4.80. Okay, what do we do now? Well, we know that you've got we know that we've got one. Is that coming back? That just jumped, didn't it? Go away. We're back. Right, we've got one adult ticket. So we've got one adult ticket, which we know is £16 left to pay after he's used his rail card. And we've got 2 child tickets. He's got 2 children. So we've got 2 child tickets. So that's 2 times our £4.80, which is what he's got left to pay after he's used his rail card. Okay, so what's that give me? That gives me £16 plus, I make that £8, £9.60. So what's the total cost of the tickets? We're going to do 16 plus £9.60. Okay, I reckon that's £25.60. Okay, now if you weren't sure there, we could do some column addition. We could add £10 on, that makes £26, and then take 40p away. Okay, I reckon £25.60. Okay, now let's look at the higher tier question, although it could appear at the end of the foundation tier as well. Okay, we've got the distance from Fullback to Gamby is 10 miles. Okay, so it shows us that nicely on the diagram here. And then the distance from Gamby to Horton is 18 miles. So again, we've got a nice diagram that shows us both of those things. Raksha is going to drive from Fullback to Gamby. Then she'll drive from Gamby to Horton. Raksha leaves Fullback at 10 AM. She drives from Fullback to Gamby at an average speed of 40 miles per hour. Raksha wants to get to Horton at 10:35. Work out the average speed Raksha must drive at, from Gamby to Horton. So we want to know the speed, the average speed, for this section of the journey here. Okay, we want to know the average speed for that section of the journey. We know some facts about the first section, Fullbeck to Gamby. So if you're not thinking speed triangle or speed equation, speed formula, okay, then something's gone wrong. Right, we've got average speed crying out in this question. We need our speed triangle. So let's first of all put that straight down. Now, you need a method of knowing that you've got this triangle right. So whatever mnemonic you're using, right, we know that we've got to put the D at the top. Okay, we've got a speed there, we've got a time there. It doesn't matter which way the bottom two go around, but the distance has got to go at the top. Because I know that speed equals distance divided by time. So you may remember the formula, you may remember the triangle. Okay, if you watch some other videos, I'll go through some methods for you learning the triangle, different mnemonics you can use. Okay, but you've got to have that in your head. You've got to be able to put that straight down on the exam paper. So speed equals distance divided by time. Right, now we know all the facts we need for the first section to calculate the time. Yeah, to calculate the time. So let's do that first. Let's say from Fullbeck to Gamby, we know we go from 10 o'clock and we know 40 miles per hour. So we know the speed. The speed is 40 miles per hour. We know the distance. The distance is 10 miles. So we've got that formula. We've got 40 miles per hour equals 10 miles divided by our time that we don't know. Let's put T, and that's going to come out in hours. It has to, because we've got 40 miles per hour. Now, if you were using the triangle to do that, we could have covered over the thing we wanted to know, which was time, and we get time equals distance divided by speed. Okay, which has rearranged our equation for us. That's going to give us time equals distance, which was 10 miles, divided by our speed, which was 40 miles per hour. So we've got two ways to do things here. We can put the numbers in straight away and then rearrange. That's that method. Or we can use our triangle to find the formula we want for time. Time equals distance divided by speed. Okay, and then our rearranging is all done for us. Okay, so times 10 divided by 40. Well, I think we can simplify that fraction. 10 divided by 40 is the same as 1 divided by 4. We can divide the numerator and the denominator by 10. So we get a quarter. And a quarter of what? Well, we know this is going to come out in hours because our speed was miles per hour. So that time is a quarter of an hour. Or, what's a quarter of an hour? That's 15 minutes. So we now know the time taken from Fullbeck to Gamby is 15 minutes. Okay, right, knowing that, how does that help us? Well, Raksha wants to get to Horton at 10:35, but she leaves Fullbeck at 10. Okay, so what time does she get to Gamby? Well, she leaves Fullbeck at 10. Okay, we now know it took her 15 minutes for that first section. So she must get to Gamby at 10:15. Right, that's the first step of working this out. So we need to know that she gets to Gamby at 10:15. Right, what should we do next? Raksha wants to get to Horton at 10:35. Well, if she wants to get to Horton at 10:35, and we already know she's at Gamby at 10:15, that journey's got to take her 20 minutes. Right, it can't take her any longer, otherwise she's going to get there after 10:35. So work out the average speed Raksha must drive at from Gamby to Horton. Right, so that means that we need her to cover 18 miles per 20 minutes. Her speed will be 18 miles divided by 20 minutes. Now we could do some converting of those units here, but we can think this through and make it a little bit easier. If her speed is 18 miles per 20 minutes, it would be nice if we could get that in miles per hour. So what would we do to the top and the bottom of this equation? Well, if I want the bottom to say an hour, we could get it to 60 minutes. So if I multiply the top and the bottom of the equation by 3, sorry, not the equation, the top and the bottom of the fraction by 3, okay, that bottom, the denominator, will turn into 60 minutes. Okay, but to do that, we've got to multiply the top by 3. So 18 times 3 is 54. So just by converting that 20 minutes to 60 minutes by multiplying by 3, we do the same to the miles. We've got 54 miles per 60 minutes, or 54 miles per hour. Okay, so that's our answer, it's 54 miles per hour. Let's just think that through again. We had 18 miles covered in 20 minutes. If we cover 18 miles in 20 minutes, how many miles are we going to cover in 60 minutes? Well, it's 3 times the 18, 54 miles per hour, 54 miles in the 64 minutes. Okay. Right, if you preferred to stick with the equation, okay, we had S equals 18 miles divided by 20 minutes. What's 20 minutes in hours? Well, it will be 20 divided by 60. Okay, we get a third on the bottom, 20 divided by 60. Okay, 18 divided by 1/3. Okay, now 18 divided by 1/3, that's the same as 18 multiplied by 3. So again, we get the same answer. Right, whichever way you prefer, okay, thinking it through, or being really careful with changing the units on the denominator of that equation, we're going to get 54 miles per hour.